Hello, distance learners. In your notebooks, you can mark that it's Friday, May 15th, and the title can be 9.6a Making Predictions with Probability. So, yesterday we talked about the difference between theoretical and experimental probability. Today, we're going to be using those two different types of probability to make predictions about situations in the future. So remember, probability is the chance that a certain event will occur. We put our desired outcome over the total possible outcomes. Probability is just a ratio or a fraction, and a fraction can be written as a fraction, a decimal, or a percent. The theoretical probability is what should happen prior to an experiment, and the experimental probability is what actually happened. That's after the experiment. So let's take a look. A Cupcake Social is a Minneapolis food truck that sells gourmet cupcakes. The table shows the flavors of the last 100 cupcakes sold. What is the probability of each flavor? Write your answer as a fraction. Whenever we write our answers as fractions, we always simplify them down. The total amount of cupcakes that were sold was 100. So each of our fractions will start off as a ratio over 100. So strawberry cheesecake, SC stands for strawberry cheesecake. We had 30 out of 100. We can simplify that down by dividing both by 10 and get 3/10. Snickers bar. Snicker bar would be 24 over 100. 24 can be divided by 4, and 100 can be divided by 4. 24 divided by 4 is 6, and 100 divided by 4 is, not 100, is 25. Then extreme fudge is 28 divided by 1, or 28 out of 100 that were sold. We can divide 28 by 2 and 100 by 2, and we get 14/50. I believe that we can divide those by 2 one more time, and we get 7/25. And worms and dirt. Got the Oreo, a little bit of gummy worms. Ooh, that makes me want some. We've got 18 that were sold out of 100. This, I believe, we can only divide by 2. 18 divided by 2 is 9, and 100 divided by 2 would be 50. So our chances of selling a worms and dirt would be 9/50. Our chances for extreme fudge would be 7/25. Our chances for the Snickers bar would be 6/25. And the last one of strawberry cheesecake would be 3 out of 10. All right. A jar holds 7 red, 3 blue, and 10 green marbles. Our marble is chosen at random from the jar. If there were 100 trials, how many times should red be chosen? If you remember from yesterday's video, this is like the last problem of that video, where we use the probability, the current theoretical probability, to make a prediction about what will happen in the future. So, first off, 7 plus 3 plus 10 more is a total of 20 marbles. Now, we're trying to find the probability of the red marbles, and there were 7 red. So the theoretical probability of getting a red marble is 7 out of 20. We're saying that there's going to be 100 trials. So we're going to set up a ratio where the total amount of trials in our experiment is going to be 100. We then have to determine what is our connecting number there. Well, 20 times 5 is 100. If we don't see that connection really easily, in some situations it won't be a nice, easy multiple. We can always remember take 100 and divide by 20. Then whatever number we get there, in this case will be 5, we multiply that by 7. So we're multiplying 5 by 7, and we're getting a prediction of 35 red marbles. That is not necessarily how many would happen. That is what we are predicting will happen. The next one. Puppy Pals will connect to Bluetooth through your smartphone. The manufacturer inspects 300 of the Puppy Pals and finds 288 of them have no defects. A defect is something that's wrong. So no defects means they're working in prime condition. The manufacturer sends a shipment of 1,000 to sell. Predict the number of Puppy Pals that will have no defects. So currently, in the sample that we took, 288 have no defects over the total that were created, which was 300. Now, we want to know what that fraction would look like if we sold 1,000 of those. This is one of those times where our connecting number is a little bit more hidden. So 1,000 divided by 300 is 3.3. Repeating. So we're dividing the 1,000 by 300, and then we're going to multiply by that same number that we just got. So we're taking that, and you can just multiply by 288 and get a total of 960 Puppy Pals with no defects. Which means that there would be 1,000 minus 960, 40 Puppy Pals that have defects. So maybe it doesn't connect to Bluetooth right, maybe one of his ears is ripped off or something like that. Okay, so this can be used to kind of determine if these were made at a high quality. If that number gets to a large enough value, the manufacturer might make a change so they're having less things with defects. And the last question is about those cupcakes that we used before. So the cupcakes in the table shows the flavor of the last 100 cupcakes sold. The baker plans to bake 450 cupcakes. Based off the sales, how many Snicker bar cupcakes should she bake? Since we're not selling each of these cupcakes at the same rate, like the strawberry cheesecake is sold at a higher rate than the worms and dirt, we're going to more than likely make more of the strawberry cheesecake so we don't have an extra amount of the worms and dirt and not enough of the strawberry cheesecake. This is where probability can help a business owner. So our probability, this one is talking about our Snicker bars, our probability for Snicker bars was 24 out of 100. Okay, now that did reduce down to, 6/25, but we can keep it as 24 100ths for this problem. We're now going to make this 100 into 450. And we want to know how many Snicker bar cupcakes we should bake. So we're going to take that 450 and we're going to divide by 100. We get 4.5. And so we're going to take 24 and we're going to multiply by 4.5. So that's 24 times 4.5. And that would give us a total of 108 Snicker bar cupcakes that we should bake. So of that 450, 108 of them should be Snicker bar. All right, good luck. You got a few practice problems, and have a great day.